the next parameter is the frequency. So frequency is usually measured in plots and can be defined as the percentage of possible plots within a sample area occupied by the target species. Okay, so you can visualize frequency by imagining the sampling area overlaid with a grain of cells the same size as the frequency plot, and then the percentage of cells occupied by the species is the frequency. Occupation is defined by occurrence. The abundance of the species within the plot does not matter, only whether it is present, because the target species will more likely occur in very large plots compared to small ones. Frequency is a measure dependent on plot size and shape. So frequency values from different studies are not comparable unless the plots used were identical. So frequency is appropriate for any species growth form. It is especially sensitive to changes in spatial arrangement. It may be appropriate for monitoring some annuals whose density may be vary dramatically from year to year, but whose spatial arrangement of germination remains fairly stable. Rhizomatous species, especially graminoid species growing with similar vegetation, are often measured by frequency because there is no need to define a counting unit as with the density. So frequency is also good. It's also a good measure for monitoring invasions of undesirable species, like what I always do when we study about the weeds, especially me in the rice field, of course. Okay, the key advantage of frequency methods is that the only decision required by the observer is whether or not the species occurs within the plot. Technicians can usually measure frequency with minimal training on methodology and species identification. If the species is easy to spot, frequency plots can be evaluated very quickly. So to design and consider measuring frequency in the field, you can locate frequency plots randomly or along transects. Okay, plots arranged systematically along random located transects are more efficiently located in the field than plots that must be located individually at random coordinates. Thus, using transect is the most common approach. Of course, you can also incorporate quadrat to determine the density. The key decision in frequency measures is whether the species occurs in the plot. While this is relatively straightforward for single small stemmed plants, it is more difficult for larger plants and the method plants. Okay, you must establish counting rules and apply them again consistently. As with the density, you must decide whether to evaluate occurrences by size or stage classes, again like such as seedling, reproductive, vegetative. So using stage classes increases the amount of time required to evaluate each plot, but it can dramatically increase the understanding of frequency change in many cases. At a minimum, consider separating classes by seedling and the vegetative or not the non-seedlings.